Very, very quick PowerPoint now. Should have tacked it onto the end of the last PowerPoint, but it won't take very long. It's just on the periodic table. Now you need to know your way around the periodic table. It's not just this random assortment of hieroglyphics. There is some order to it. Now the first thing is that you have your vertical groups. Now those are the columns. So column 1, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. And then you've got column 2, beryllium, magnesium, calcium, strontium, barium and radium. So your vertical groups, your vertical columns are called groups, okay? So I'll talk about group 1, group 2 and so on and so forth. Now your horizontal rows are called periods. So period 1 has just got hydrogen and helium in it. Group period 2 has got lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon in it. And so on and so forth, group 3, 4, period 3, 4, 5, 6 going downwards. So I could find any element on the periodic table by saying what is in group 2, period 2, and that would be beryllium. If I said what's in group 1, period 3, that would be sodium. So that's groups and periods. It's basically columns and rows, or verticals and horizontals. The next thing you need to know is if you look over to the right hand side where you see B and SI and AS and TE and AT, there's like a bold line where there's kind of a staircase going down. Now everything on the left of that staircase is a metal. So aluminium is a metal, and then if you go above the staircase, boron, that is not. Carbon's not, nitrogen's not. So everything on the left of that little staircase there is a metal. So most of the periodic table is constructed of metals. Next thing, the ones in red, as it says on here, are gases, the ones in blue are liquids, and the ones in black are solids. So there aren't many liquids. Now this is at room temperature. If you change the temperature, if you got up to 500 degrees C, this would look very different. But at room temperature, there's only two. There's Hg, which is mercury, and there's Br, which is bromine. Those are the only two liquids at room temperature. Let's have a look at this more colourful version. Now, the groups. Look at group 1, hydrogen, lithium, sodium, H, Li, Na, K, Rb, so on and so forth. That's group 1. Then we have group 2. Now, ignore the next bit. Ignore the transition metals, the sort of light grey colour ones in the middle. Skip all the way along to that pink one, the B in group 3A. That we call group 3. Okay, so group 1, group 2, skip that little box, and then group 3, C carbon is in group 4, N nitrogen is in group 5, oxygen is in group 6, fluorine is in group 7, and helium is in group 8. Okay, so we've got 8 groups, and just don't count that central part. Okay. If you go on to do A-level chemistry, that will become clear why that's there, but for the moment we just don't need to think about it. It will confuse things if we did. So if I said what's the first one in group 2, you'd say beryllium. If I said what's the first one in group 4, you'd say carbon. Okay. Now you don't need to know many of these elements. You don't need to know what they are, what they do, or how they are, but there's a few groups that you do, and the first one is group 1. Group 1, and don't worry it says 1A, we're not going to use A and B and all this, it's just group 1. Lithium, sodium, potassium, all those. These are what's called the alkali metals, and they're all similar. They're all very soft. You could cut them with a knife. They're all very reactive. If you throw them in water, they explode, or they give off a flame or hydrogen gas or something like that. They're called the alkali metals. When you put them in water, they produce a hydroxide which turns the water alkali. That's why they're called the alkali metals. So that group all have something in common. If you shoot all the way across to the green section in group 7, fluorine, chlorine, bromine, iodine, astatine, and I don't know what UUS is, but it's in group 7. Those are your halogens, and they have certain sort of properties in common as well. The last group that you have to know about is the group 8. Now those are your noble gases. Now those guys have 8 electrons in their outer shell. That means, and if you remember from the last video, they have a full outer shell. They're happy. Helium's got 2 in its first shell, so it's got a full shell, so it's happy. It doesn't want to react with anything. Helium does not want to get rid of any electrons or gain any, and because of that it's unreactive. Neon's got 8 in its outer shell. If you can see the little number there, it's 10. So if you remember back, that means 2 in the first shell, 8 in the second. That's 10 electrons. So neon has a full outer shell. It's happy. It doesn't want to lose any electrons. It doesn't want to gain any electrons. This makes it very unreactive and stable. And the rest, argon, krypton, xenon, and so on, they are all the group 8s are stable. They don't react with anything. So the columns, the groups, all share. They're like a family. They all have something in common with each other. So the periodic table isn't just this assortment of hieroglyphics of letters and numbers. It actually makes sense. The more you come to study it, the more you realise that each bit makes sense. So those are the 3 that you have to know. You have to know about Group 1, Group 7 and Group 8. And in future PowerPoints we're going to go into those 3 groups in a bit more detail. Last thing I have to say is the group is the number of electrons in the outer shell. So if I said lithium to you, look way over to the left, on the far left hand side, just underneath hydrogen, lithium. Lithium is in group 1. What that means is it has 1 electron in its outer shell. Okay, so it's got 2 in the first and 1 in the second. Sodium's the same, Na, just underneath it. It's got 11. What does that mean? It means 2 in the first, 8 in the second, that makes 10, and 1 in the third. And potassium's the same, and rubidium's the same. They get bigger and bigger as you go down, but they only have 1 electron in their outer shell. Now that means they're very reactive. It means that all they need to do is get rid of 1 single electron and they'll be happy. So the group 1s are desperate to get rid of 1 electron and then they'll be happy. So they're quite reactive. Go across to the group 7s. It's in group 7, so they have 7 electrons in their outer shell. If you don't believe me, fluorine's got a 9, so that means 2 in the first, and 7 in the second. That makes 9. So fluorine and chlorine, bromine, iodine and all these, they have 7 in their outer shell. Now if they've got 7 in their outer shell, how many more do they want to be happy? Well, they want 8, don't they? So they only want 1 more. So hang on a minute. Group 1s want to get rid of 1 and group 7s desperately want 1. So they're perfect for each other, and this is why you see salts like sodium chloride and lithium chloride, potassium fluoride and things like that. The group 1s and the 7s go together very, very well. So in boron there's 3 electrons in the outer shell, in nitrogen there's 5 in the outer shell, in helium there's 8 in the outer shell. Whatever group it's in, that is the number of electrons there are in the outer shell. You don't even need to look at the numbers, okay? So that's it. That's the periodic table. A quick, very quick look around the periodic table. You know now which ones are metals, which ones aren't. You know what group 1, 7 and 8 are. You know about some of their properties. And you know that the group they're in is the number of electrons in the outer last shell. Good. Okay, so once again, I've got 6 questions for you to do. Pause the video and have a go and check your answers. Thanks for watching.